Hi and welcome to my video about finding areas between two curves. So I'm going to show you this basically through an example, and we're going to do it by first determining our two curves. And so the two I've come up with are y equals x squared and y equals negative x squared plus 8. Again, I've done it very deliberately. I'm not really relying on technology in these videos. You might get a harder question. In fact, you'll certainly get a harder question in some of your exams and practice exams, and you might have to find irrational points of intersection, and it could get a bit crazy, but for now, let's just deal with this one. And it's a good place to start. So here's my function first of all, and it looks a bit like this. The first one is y equals x squared. Goes up like that. Goes up like that. Here's my y-axis. Here's my x-axis. And the second function, so that's the yellow function, second function is negative x squared plus 8, which I'm going to define as going down like that, down like that. It's not a perfect diagram, in the sense there's a bit of a lack of symmetry, but hopefully you'll get the idea from my diagram. Now what I want to find is the area bounded by these two curves. I'm going to call it the blue area. Now think about the theory here for a second. To find the blue area, what I need to do is find, from this point to this point, I need to find the area under the pink curve, and I need to subtract from that the area under the yellow curve. So that is the yellow areas here, whereas the pink area will be the blue area plus the yellow area. So if I can find that pink area and subtract from that the yellow area, then I'm all good. And so we'll say the total area, which I'll call the blue area total, blue is going to be funny, will be equal to the pink area pink, minus my area yellow. Now what does this look though? What does this look like mathematically? How do we do this theoretically? Well, what we do is we say we want to find the area total, and that's equal to between B and A, so I'm defining this as B and this is A, of f1 of x minus f2 of x. Our two functions, just a badly drawn bracket, sorry about that. f1 of x minus f2 of x between B and A. What we don't know now is which one's f1 of x, which one's f2 of x. We want upper minus lower, and what is A and B. So that's what we're going to have to determine first of all. So, first of all, the pink one is upper and the yellow one is lower. And this is my pink one here, and this is my yellow one here, because you saw that as I drew them. The yellow one is just the basic x squared, and the pink one is negative x squared plus 8. You might have to do that determination yourself though. Maybe graphically, maybe using some understanding of functions. So that's going to be my f1x will be this one, and my f2x will be this one. That's the first thing. The second thing is, what are a and b? Now a and b occur when I let the functions be equal. That's how I find my points of intersection. So to find a and b, well I shouldn't have really written that as a coordinate. Let's just rub that out. A plus b, I have to do this. I have to let f1 of x equal f2 of x, and that will give me my points of intersection. So to do that, I go x squared equals, so let's make it negative x squared plus 8 equals x squared, which gives me 8 is equal to 2x squared, which gives me 4 is equal to x squared, which gives me x is equal to plus or minus 2. So this is negative 2, and this is positive 2. That makes sense in my diagram. You've probably already got affirmation of that from a calculator, so that's good news. Now we're going to find our area total. And so to do our area total, we're going to go through that process again that we were doing earlier with this definite integration. So the area total will be equal to the integral between 2 and negative 2. And we can include negatives on our terminals here, of f1 of x, which is negative x squared plus 8, minus f2 of x, which is x squared dx. Now I could find the pink area as area 1 and then the yellow area as area 2 and subtract. That would work perfectly well, but it is an extra stage of working. So what I'm going to do is just do the subtraction in the initial integration, and in this case, because the functions are both quadratics, it actually simplifies it out a little bit. 2 and negative 2 of negative 2x squared plus 8 dx. Now, I'm a little bit worried about space, so I'm just going to pop it over here, and my area total will be equal to, and I'll do my evaluation now. Negative 2x squared becomes negative 2x cubed over 3 plus 8x between 2 and negative 2, and this becomes negative 2 times 2 cubed over 3 plus 8 times 2, and I don't need the square brackets now, this is circle brackets, minus, so that should be negative 2, I'm really desperately want to do that, negative 2 cubed over 2 plus 8 times negative 2. It's a bit complex now, you'll probably pop this in a calculator, but I can see this is negative 16 on 3 plus 16, and then I subtract negative, now this, negative 2 cubed is negative 8, negative 2 times 8 is now positive 16, but I subtract it, so it's negative 16 over, that should be a 3, and then minus negative 16 gives me plus 16 again, that gives me 32 minus 32 over 3, and that's equal to 64 over 3 because 32 is 96 over 3, and of course I'm finding an area, so that's units cubed. Now I can play around with this, I can do a little block box. What's this? It's got a width of 4, it's got a height of 8, 4 times 8 is 32, this is a bit more than half of that 32, 64 over 3 is about 21 and a third, so that's a bit more than half of 32. I'm pretty happy with that answer. It's always good to do that little estimate at the end to make sure that it suits what you expect to get, or the easier way of doing the estimate is if it's a tech active paper, you just pump it straight in your calculator and you'll get the exact answer that you expect anyway. So that is finding the area between two curves.